I hope my screen is visible to you all, sir.
Yeah, it is visible and audio also very clear, sir. Thank you.
Yeah, fine. Yeah, yeah. So in the last class, in the last session, we discussed about uh, the diagrams, right? So bar diagrams, pie charts, and then multiple bar diagrams, and then histogram, box plot, and a small testing of normality Shapiro test. Yesterday we stopped here, right? Box plot. Yeah. So these are the tests we yesterday these are the diagrams we have discussed yesterday. So these diagrams are completely one-dimensional diagrams because only one axis we are accessing, and then we are drawing the diagrams. So today we'll go with two dimensions and three dimensions, and if you have more than two dimensions, how we will visualize. And once we visualize the diagrams and how we can go for the further little data analysis, that we will discuss today. Okay, so I'm taking the new R script, this one R script. Yeah, this is the new R script I have taken here. Now let's go with two-dimensional diagrams. Two dimension. Generally, whenever we are discussing the two-dimensional diagrams, many people will get an idea that, so if you want to represent the data in a two-dimension, mostly we will draw a scatter diagram. Okay, that is mainly will be useful to understand how the data is scattered. Okay, so with this scatter diagram, we can understand that. So whether the what is the relationship between two variables? So what is the pattern of the relationship between two variables, either increment or decrement? So what type of relationship exists between two variables, that we will come to know easily. Okay, and based on that scatter diagram, if there is any pattern is identified, that then we'll go for the regression analysis. Okay, a basic step while we are doing for regression analysis. Okay, so if for example, if you have two variables and you want to fit a regression model between these two variables, so initially we have to verify whether these two variables are having some relationship or not. If there is no relationship, then no use of fitting regression model. Okay, for example, let us take the students, their marks and how they are coming to the college. Now, see how they are coming to the college by car, by bus, or is completely independent that how they are getting marks. So there is no any relationship between marks and how they are coming to the college. So this is completely independent. But if you find the relationship, it will get zero, and we cannot estimate, we cannot fit the regression model between these two variables to estimate the student marks based on their coming vehicle. So this is irrelevant. I mean, understand. So before going to fit a model regression, fitting the model, so or simply I'm saying regression model. So first we have to verify that whether the two variables are the variables what we are considering into model should be some relationship exist, and also that relation should be significant. That we have to focus first. So to know this relationship between two variables, generally we will do correlation. Okay, correlation is a numerical proof that the both the variables are related to each other. So other than this numerically, we can go with graphical also. Using graphs, we can understand that whether these two variables are related or not. So one of the best graph is scatter plot. So scatter plot will be useful to know the relationship between two variables or how the data points are scattered around the plane, two-way plane. Okay, that we will draw today. Okay, shall we take other same data set, or we go for any other data set? Yesterday we worked with the air quality, right? Today we'll go with any other data sets. Let me search any one data set. I need some variables at least. At least anyone, if you have any idea about any data sets, please let me know by the time by searching. Iris, we have data with three variables. This is everyone will work generally. Empty cost is a common data set. Penguins is the measurements on penguins near Palmer Station under Antarctica. Anybody is having any information about any data set so that we quickly will access. Swiss data set, Swiss fertility and socioeconomic indicators. We'll get some average heights and weights for the American women. We'll go with this one. Women, we'll see why there are variables. We want at least more than two variables, because next we'll go for a three-dimensional diagram representation. Quickly, I will see what is the variables available. Women. Otherwise, simply go for head of the women. This is only two variables, height and weight. Uh, Okay, we'll discuss this one again. By the time we'll go for any new data set for 3 dimension. So as of now, we'll go with these two variables. Okay. So women data set. First, let me give you clarity about this women data set. What is this description? So just keep question mark before the data set name. Then I'm executing this one. I'm pressing Control Enter. Okay. I'm not clicking this run button here. Directly I'm using this Control Enter. Okay. Uh, Someone texted, right? Empty cards. Okay, madam. Trees. Empty cards. Trees. Okay, madam. I will take. I will take. So I have taken one data set, that is women. So let me discuss about this two dimension only, right? So this is enough for our scalar diagram. Then I will go for empty cards. Okay. Yeah. Yeah. See this one data set. Average height and weight for American women. This data set gives the average heights and weights for American women aged 30 to 39. Okay, fine. Data set is having 15 observations, only 15 observations on two variables. Okay, well, this is very small data. Okay, fine. We'll go with this. And then the details is given. Actuaries build and blood pressure study for someone known. The source is old American. Okay, no issues. This is already they have taken, right? See, they have performed this scalar diagram. Already they performed, right? You will easily understand from here. Only this. Okay, I will go with empty curse. Then that is fine. Why I'm changing the data set is already they have performed here. You can see this one. Plot. A plot is a command to draw scalar diagram. Okay. Does not again repeating this may not be good. That's why I'm going to change. You can copy this code and you can execute directly. Will get the uh, scatter diagram. Okay. Let us take empty cars. Yeah. I will increase this one size. This I know some information about this empty cast data set. If you want, I will visualize this for you people also. What is the description about this empty cars? Here you can see this. So empty cars data set is nothing but it is a motor trend car road test. I think it is collected from US magazine. Okay, this data set is having 32 observations on 11 variables. Here we have the data frame with 32 observations on 11 numerical variables. These are the variables. MPG, miles per gallon. Because in our India, we are measuring kilometer wise, right? But in USA, they are measuring gallons. Okay, here we are measuring what is the mileage per kilometer? Their miles per gallon. Next, CYL, number of cylinders, displacement, the car displacement, wheel. Next, HP, the horsepower, drag, that is a relaxation ratio, and weight of the car, QSEG, volume surface, either is V-shaped or straight. AM, it is a transmission, either is automatic gears or non-automatic gears. They have taken zeros and one, and a gear, number of forward gears, how many gears are there, and number of carburetors. So this is the 11 variables. Easily we can understand that if you have little idea about the vehicles, easily we can understand the data set. Okay, there are 11 variables are there. Okay, so with this data set, we'll go for complete analysis today. Easily we can do. Why? Because more number of variables are there. We can visualize. See, for example, let us take. I will go with a simple scalar diagram. So plot. So if you want to draw the scalar diagram, the code is plot. Okay. And one more thing, for example, let us take after this analysis, I will go for little correlation regression, right? So whenever we want to find correlation regression, as I said that we need some relationship between two variables. Okay. See, for example, let us take miles per gallon (mpg). If I take this variable, definitely the mileage may come. We know that the mileage depends on the weight of the car. If you have more weight of the car, definitely mileage will be very less. If you want, simply we can say the examples also. Let us say the two-wheeler vehicles. If I take, recently I purchased one bike. That is, my bike is Honda Hornet 2.0. So the weight is very high. The weight of the car, my bike is high. So with that, I will get mileage is very less. I got around 45, 46. And CC also less. Okay, if the horsepower and weight of the car is more, automatically will get less mileage. It is inversely proportional. You can take Royal Enfield. Royal Enfield bikes are very high, heavy height, right? The heavy weight, right? So if you have heavy weight, automatically their mileage is low. And we can take one more vehicle. Recently, this not recently. What is the name? Uh, Platina. TVS Platina. If you Bajaj Platina, sorry, Bajaj Platina. If you take the bike, the Bajaj Platina 110 cc. Cc carbon capacity is very less. That the horsepower is very less, 110 cc only, and less weight of the vehicle is very less. So which is giving more mileage, around 65, 67, 70 like that. It is touching. So when the weight and horsepower is less of the vehicles, then automatically will be more mileage. So same thing here. If I take the mileage of the cars, so car mileage sometimes depends on the horsepower and weight. So let us just will take with these two variables and we'll understand what the relationship exists between two variables, MPG and weight. So if I want to discuss about this MPG and weight, we know that MPG weight, so miles per mileage and weight is almost inversely proportional. We will get negative correlation, right? Which means that if weight is increasing, then the corresponding mileage will decrease. So these two variables are in opposite direction, their effect. If they affect on both the variables in the same direction, we will say that positive correlation. If their effect is in opposite direction, one is increment direction, other one is decrement direction, the rate of change is showing the effect, and the other variable is in opposite direction, then we can say that there is a negative correlation. Okay, we know that positive, there are two types of correlations, positive correlation, negative correlation, and then there is zero correlation, that is independent. Both the variables are independent each other. Okay, that's we will check today. Okay, plot. I'm taking what are the variables? One is MPG and weight, right? MPG and comma weight. See here I'm accessing direct variables. If you're directly accessing variables, it will not run. See, for example, see object MPG not found because of I did not attach my data to R console. Now I'm going for attach. Yeah, attach empty cards. So with this command, I have attached my data set to my R console. Now I can access directly variable names, that is MPG and weight. Now if I draw plot MPG weight, yeah. So this is the diagram I got. You can see this one. Okay, let's go with the fine. We'll keep this top. We'll give some title for this one. Title, how we will give, we can give main, right? So main equal to within the double quotation, scatter plot between mileage and weight. Yeah, so I got scatter plot between mileage and weight. X-axis, you know, X lab. Y-axis, Y lab. Already we know these arguments. I'm not teaching again. Why? Because by default we got some here MPG weight, so I am not going to change. If you want to change, go for X lab, which is equal to in the double quotation. You can mention Y lab. You can mention the name. Okay, and then if you want to give a color for this circles, you can give color COL equal to. So let us take COL which is equal to some red. I hope this also I already thought. Yes, now we got the red color. Here one more thing I will teach you today. See here, you are representing the data points in a circle wise, right? Circle around round circles we are representing data points. So these data points you can change to different symbols. Either if you want dollar, or if you want to ask, or if you want to any separate stars plus like that, you can take. So to change this one, you have to use the argument PCH. This is a pixel something they will call. So PH you can call this. You can use this argument to change this data points indication. Okay, the PCH value is takes from 1 to 25. There are different types of data points representations are there. So there are 25 are there. That's why they mentioned they have given number 1 to 25. So you can give any number between 1 to 25. There is that corresponding symbols will represent the data points. Let us say I will give 5. Okay, if I run this one, see now if I run the 5, so it becomes now like a diamonds. Or let us say I will go with 15. Now we see if I give the 15 PCH value, then it has become a rectangular, sorry, square box with filled red color. Okay, let us say we'll go with 3. Yeah, we got the plus symbols. So however you want, you can represent your data points by giving the PCS values from 1 to 25. Randomly, I will give 10. I will see this is okay. Otherwise we'll go another 15 is fine. No, let us take 13. I will give sometime. I want some stars type, but remembering of each and everything with their notations is difficult. Okay, that's why I am not. I didn't remember anything. Simply, I will give randomly some data points. Okay, let's go with these data points with star marks, cross marks. Okay, now these are the data points. Now you can see this. The data points is plotted from top left corner to is so going something pattern towards right below corner. See here from top left corner to data points are going to be below right corner. So what is the meaning? If the mileage is 10, their weight will be around more than 5. Maybe in kgs or maybe in tons something they have mentioned. Okay, let us assume that at the mileage 10, so the weight is 5. Next, if the mileage is increasing at the mileage 15, so the weight will become down 4. Earlier it is 5, now it become down. So at the same time, if I go for 20, there are some points which are the weight is very less 3. Keep on, if I increase the mileage, if I go here 40, so the weight is 2 something. So what is the meaning of this one? If the mileage of the cars is increment, then the corresponding weight should be low. It is a decrement pattern, right? Here you can see this one. Data points are in a decrement pattern. So when the data points are decrement pattern in the scatter plot, this means that there is a negative correlation exists between the variables. And also, if these data points are very close to each other, here almost some little scattered, right? It is going downwards only, but little scattered. If the scatterness is very close, which is forming around straight line, negative straight line, then we can say that there is a perfect negative correlation. Or if these data points are in increment pattern like this, so from mileage increasing, weight is increasing. Later, if the data points are from left below corner to top right corner, if it is increment direction, then we can say there is a positive correlation. Okay, so by seeing this scatter plot, we can understand that the relationship between two variables are negatively related. As I said, right, scatter plot will be useful to understand the data pattern as well as to find the relationship between variables. Okay, now here we understand that there is a relationship between two variables and the data pattern is showing that there is a negative trend in the data. Okay, maybe this we can consider as a regression model. So to fit a regression model between mileage and weight, so that we can estimate mileage based on the given weight. Okay, very simple, right? So like this, we can draw the scatter diagrams. If you want to change the values, whatever, you can change. You can go for any data set. The code is set plot. Plot of two variables gives just to give two variables. After that, what are the arguments if you want to add, you can add. These are the extra flavors, color, PCH, main. These are all we are adding some extra flavors to show our data or our diagrams in a beautiful manner. Okay, so mainly in two dimensions we will discuss this plot, scatter plot. Okay, we can draw many diagrams of two dimensions. Just we'll go with this. This is fine for us because of for our statistical diagrams mostly will depends on the scatter plot. Okay, quickly I will go for three dimensions diagrams and then we'll go for matrix. Let us take three dimensions, 3D plots. Now see here, 3D plots if you want to draw, we have to install the package. Here we can draw, generally 3D means three dimensions will be the right, X, Y, Z. So two diagrams I will show you. One is three dimension, another one is three dimension with rotation. We can rotate the diagram so that we can see that where data points are scattered. But the problem with this three dimension is nothing but interpretation is will be difficult. Whenever we have when we are seeing the data in three dimensions, looking is very beautiful. To looks, the data will be very beautiful, three dimensions. Okay, our mind and the easily will access, but understanding the 3D points where data points are scattered, that will be little tough. Okay, yeah, so to go with these 3D diagrams, so we need to install the package. Okay, uh, yeah, I want to draw some 3D plots. Let us take first. I will show you rotatable graphs. Then we'll go for rotatable 3D. Then we can go for normal 3D. Okay. If you want to load, if you want to present the 3D diagrams, rotatable 3D diagrams, we need to install the package that is called RGL. RGL is nothing rotatable graphs. Okay. Install this one. We know right now how to install. Just clicking the package and going for install option. Next RGL, just search like this RGL. Okay, if you have internet connection, no, just if you enter the letters, automatically the corresponding suggestions you will get. So here is, if you select RGL, install this package. Yeah, installing packages. Here I will write RGL package required. Yeah, it is installed. Now I will search here RGL. Yeah, 3D visualization using OpenGL. The description about this package. Just check box this one. It just means we are loaded into our R console. Initially we have downloaded. Now we are loaded into our console. Yeah, it is executed. Now we got the prompt. Now I will use this one. So here we use a plot, right? Same command, plot 3D. See, you got this plot 3D. Click this one. See, earlier we were using plot, now plot 3D. Okay, now we have to give three variables. What are the three variables we'll give? So one is MPG will give, and other one is weight will give, and we'll give one more variable. Let us say horsepower, HP will give. Three variables. I want to see what is the data pattern in the three-dimension diagram. Okay, if I run this one, yeah, here you can see this. The code is executed. Plot 3D MPG weight horsepower. The command prompt is also showing, but the output is not showing here. You can go for plots. There is only a two-dimensional plot. Where is a 3D diagram? Many of I got experience that many of our students will raise a question. If we are teaching any labs, they will ask, sir, we draw three diagrams, but 3D is not showing. So to see that one, see, once this 3D diagram you have performed, then in the below you can see here the new window is created. One new window is created. So why? Because this is 3D diagram, right? So 3D rotation we are creating. Rotation is not possible to rotate in this area, in this help window area. To rotate the data, that's why it is created new window. Okay, click this one. This is the 3D diagram. Now click here, zoom it. Now see this one. This 3D diagram for a scatter diagram, for a scattered plot. Okay, now you can hold, you can with your mouse, we can rotate this one. See, we can see however you want, from top to bottom or below to above, however you want, you can see. So best way we can see this one. Let's go with like this, or any 3D pattern you will take. See, this is a beautiful of R programming language. You can rotate however you want. Yeah, this is okay. Like this will take. This is fine. This is also somewhat. You can take like this to interpret the results. See, for a weight, a mileage, and a horsepower, data points are almost towards increment pattern. So sometimes weight and horsepower may be in one relation, and my mileage and weight will be another relation. Maybe you will get. Otherwise, all are in increment pattern, positive correlation, or decrement pattern, negative correlation. If we go for above. So this is the problem with interpretations of three diagrams. It looks very beautiful, but the problem with these interpretations. Okay, I hope you understand this one. I'm closing this one. If you want, again you run, and then you can give the colors, titles, everything will be same. Okay, you can use the same PCH values and all. Otherwise, we'll go for one more scatter plot. That is scatter plot 3D. Again, we need a package. Let us think I will install scatter plot 3D. This is also package required. Packages, install scatter 3D. Here you have scatter plot 3D. Use this package, install. Yeah, it's installing. Yeah, install. Now I will search here whether it is installed or not. Yeah, install. Check this box. Now I have loaded into my R console. Same here, scatter plot. Below you get scatter plot 3D. Okay, what are the values? We have 3D, MPG, and weight, and horsepower. This is not a rotatable diagram. Only RGL, under RGL package, plot 3D is only rotatable. Okay. This is a proper way of looking the three-dimensional diagram. So MPG horse power weight. We give PCH something, PCH equal to, let us say 15. This is the way properly we can look at how the data points are increment or decrement. Here we can observe that somewhat mileage and weight will be in one direction and horsepower and weight will be another direction. Okay, little tough to understand this three dimensions, but looking is very beautiful. This we cannot rotate here. Okay, just as it is, we have to copy and we have to store in the our data diagrams in our reports. Okay, yeah, fine. So two dimensions, simply I shown this scatter diagram, and the same scatter diagram how we can draw in three dimensions. Okay, there are many plots are there, all are not teaching. Why? Because for mostly for the data analysis, what are the plots and what type of techniques we require, that only I'm teaching. Okay, yeah, fine. So for example, let us say now we have three variables. Sir, I have a data. Generally, data will have many variables, right? Now, how to visualize all the variables, sir? So is there any way to represent more than the three-dimensional data diagrams? Yes, there is a possible case, but we are not visualizing the more than three dimensions. We are visualizing the data by making pairwise. Pairwise, we are making the data, splitting the data, and then we are visualizing the data into matrix scatter diagram. Okay, that will draw now. Okay, if you want to visualize more than three dimensions, let's go with matrix scatter diagram. Don't think about the matrix. So it looks like a matrix type. Okay, matrix type is nothing. We can draw symmetric matrix. Above and below values are same, pairwise combinations, right? So matrix scatter diagrams. Okay, if you want to draw matrix scatter diagrams, simply in order to install any packages, we can use the function is pairs. Pairs is a command which will be useful to represent our data. If you have more than two variables and you want to visualize it, then if you that visualization should be in the pairwise, then pairwise if you want to visualize, you can go with this function, pairs function. Okay, what is the data set we have? Directly I will give data set empty cars. First I will go with this. I will look into it, empty cars, head of empty cars. Here, what are the variables are there? MPG, cylinder, displacement, horsepower, drag, weight, cubic. We'll take some variables. No need to take all the variables. Why? Because we should not draw a scatter diagram for count data. We know this, right? Histogram or scattered plots, all are continuous data plots, continuous data diagrams. Whenever we have data is continuous, then only we have to draw. So scatter plot we should not draw for categorical data or discrete data. See here, cylinder. Cylinder is count the number of cylinders in the data. It is discrete, and displacement continuous. Horsepower is continuous. Drag is a continuous. Weight is also continuous. Cubic is continuous. Volume surface. Volume surface 0 and 1 binary categorical variable, and automatic AM. It is also binary 1 0. And the gear, the number of gears in the car. Next, carburetors, number of carburetors. This is also count. So we should not take these variables into your drawing matrix scatter diagram. What is the problem, sir? To take this, you can take, but the graph is invalid one. Why? Because, for example, if you take volume surface 0 and 1, only once. Okay, that is a problem. Okay, yeah, fine. I will go with empty cars. What is the page empty cars data set? In this empty cars data set, I'm taking the index position. Now, in the first class, I told you how to take the index. Now, in this index, I want all the rows. In that rows, I want to access more than one column, that is C of concatenation. So before comma indicates the rows, after comma indicates the columns. Now, in the columns, I want to take more than one column, right? That's why I'm taking concatenation C. Now, C of what are the columns you want? I want first column, that is MPG, and displacement. Displacement will be the third column. Next, horsepower, fourth column. Next, fifth column. Next, sixth one. Next, seventh one. Up to here. The first column, second is leaving because this is discrete data, and third, fourth, fifth, sixth, and seventh. So these are the columns. I want a matrix scatter diagram between these columns. Okay. Just run this one. Yeah. So this is the plot we got. Now zoom it. See here. See, the diagonal elements are nothing but the variables. What the variables we have considered. Now this is a pairwise visualization. See here. MPG displacement. What is the diagram? Scalar diagram. See, MPG displacement showing negative correlation. The trend is in negative direction. And MPG and horsepower, it is also in a negative direction. And MPG and DRAT, they're slightly positive but scattered around, which means a weakly positive correlation. Very weak. Why? Because scatteredness is very high. Compared to scatteredness is very less. And here you can see this MPG and weight. These data points are scattered below, I mean downward trend, and scatteredness is also very close. So maybe we can say that there is a strong negative correlation. And MPG and QSEC, this is also weak correlation. This is weak correlation, positively weak. So data points are trends right side, but very high scatteredness. Data points very scattered very far. So this is will be positively weak correlations you will get. Now coming to the displacement horsepower, some positive, and displacement and DRAT negative, displacement and weight positive, and see this displacement and QSEC mostly no correlation or very weak negative correlation will get. See data points are below down but scattered very far. So this is may not be considerable correlation, does not require to identify. Okay, so like this we can see the pairwise combinations. What is the data diagram representations with this pairs function? Now see the below value is also same, above is same as it is below. The relation between mpg displacement matrix scalar diagram, generally we will call it as a symmetric matrix. Upper diagonal elements is equal to lower diagonal elements, symmetric matrix, right? Same thing. Here I said, right, sir, you are saying that MPG and displacement are negatively correlated, and you are saying that the data, the scatteredness is very less. So you maybe feel that it is a strong correlation. But what is how much strong? If you want to numerically, then sir, am I audible, sir?
Yeah, you are audible, sir.
Yeah, I lost internet connection. That's why they requested immediately. Yeah, fine. Yeah, so this one, right? See here, I'm saying that. So this is a negative trend, negative correlation exists. But sir, how much? I'm saying that the scatterness is very less. So maybe you will get strong correlation. But how much it is strong? You want numerical proof. And along with the numerical proof, whether this correlation is a significant correlation. Sometimes there may be some cases that I have seen personally. Let us take the relationship between two variables. If I find the relationship is 0.3. Generally, correlation is lies between -1 to +1. Minus are nothing but negatives, plus are nothing positives. Zero will be independent. There is no correlation. Now, some situations, if I got some data for I hope remember that it is for a physical education department a data set. In the data, they are asking to find some relationship between urban and rural students, their diet procedures. So in that, I perform this space function and I observe that there is some relationship. And after the relationship, I perform numerically how much they are strongly or how much they are weakly correlated to get the numerical proof. I perform correlation. In that, I came to 0.3. 0.3, what is the meaning? It is a weak correlation. 30% only, both the variables are related to each other. But if I going for testing of correlation, whether this correlation 30% is sufficiently significant to take into regression analysis or not, for testing, then it is showing a significant correlation. Even the 0.3, 30% if the both the variables related also, sometimes we will get a significant because of the data variation. Instead, the variation will be there. So taking that variation into consideration, even if you get a less correlation value, you will get sometimes significant correlation. And some situations, you will get, let us say 0.6 you got. What is the meaning? 60% both the correlations are both the variables are related to each other, which means that there is some moderate correlation between two variables positively. Even though if you have 60%, you will get insignificant correlation. That 60% is not sufficient to represent your data or to take the data into your regression model fitting. So these some situations will occur that we have to test. Finding correlation is not sufficient. Along with that, we have to test that correlation, whether this correlation is actually significant or not. That is also we can identify using this diagram directly. See, this is simply Bayes function, right? Now I will do one more function. With that function, easily you will understand that what is the correlation, whether it is significant or not. That is also usually you will come to know that. So that is the command is pairs. Additionally, you can keep dot panels. Panels is addition word. We are adding to the pairs function. But if you want to use this function, we need to load the package. That is the psych package is required, psychological term. So psych package is required to use this pairs.panels function. I will show you packages insta psych. Spelling is P-S-Y-C-H. S-Y-C, psych you can see here. Psych. P-S-Y-C-H. Remember this one. Insta. Here I will write you. P-S-Y-C-H. Package required. So it is installed. Now I will load this one. PSYC. Procedure for psychological and psychometric and personality research. The description about this psych package. Okay, and here one more thing also I want to let you know that if you are well known expert in R programming language, or if you have some coding for your research, you have your own research, and that code you have manually entered. For example, let us say if you want to find mean, what we will use here, we will draw, you will use function is mean of data. Okay, generally if you go for manually, how we will get, we'll add one by one, 1 plus 1 2 plus 3 plus add data and divide by n. We'll write the formula, right? So like this, that is the formula, and corresponding function is developed, mean of that. Like that, if you have your own research, okay, you perform some simulations like that. If you have own research code, manual code, that manual code, all these things we can convert into simple function, and then you can approach to the our producers. They will publish your packages. There are many people are doing daily. Okay, I'm also trying to develop one package for my ROC analysis. I'm doing a research and ROC analysis. So here ROC analysis only exists for binormal ROC. That is only one function is available. But what are the techniques I have developed during my PhD? So for the corresponding research, I have manually entered all the formulas and all. But instead of manually, if I click only one function, I have to perform what the methodology I have developed. Like that, I'm developing one package for the R programming language. So that is also is possible here. Okay, this psych is also developed by someone, not this R crane projects. Okay, it's a lot of packages day by day in publishing. Okay, you can also create one package and you can publish. Okay, yeah, fine. Just I'm loading. Why I gonna explain this one? By seeing this word research, personality research. I remember that one. Okay, fine. Just I'm loading this package psych. Yeah, it is loaded library. Fine. Now use this command pairs dot yes, pairs dot panels. Okay. In this I will copy the same code as for the same variables I want. Paste here. Yeah, run it. Very nice. I am going to zoom this one, close it, zoom it. Yeah, here you can see this. The same pairs function, what it is, the same thing is showing, but here a little advantage and beautiful things are there. See, the diagonal elements earlier is showing only variable names. Now we are showing histogram come overlying density. What is the histogram of that MPG and overlying density, so that we can test, we can understand whether the data is normal or not. Now MPG, if you understand, see, data is right side skewed, it is not a normal. This displacement is also not a normal. Why? Because it is scattered towards left, and this is looks like an exponential distribution. See, increment and continuous to decrease, exponential decreasing curve. Okay, so horsepower is also not a normal. Drat is looking like some bimodal pattern. So two peaks are there. And weight somewhat we can say, but right side skewed, there is a disturbance is there, and left side is flatness is there. Q6 somewhat we can say there is a normality somewhat, but not exactly. Why? Because it is showing some exactly bell shape. Okay, so like this we can see the density, sorry, histogram overlying density to understand whether the data is normally distributed or not. Okay, this one part. And coming to, I will go for below. So below is a scatter diagram. This is called scatter diagram only. You can compare it with the previous plot, same scatter diagram only, but this scatter diagram is having some trend line. The function is automatically fitted trend line. This line is continuous line is trend, and then the circle is there. No, the circle is nothing but it's the scatteredness of the data. Where most of the data points are scattered, that's they are indicating with circle. Okay, and inside this the thick blue point is nothing but it is the centroid of the data. For your data points, what is the centroid? Same situation, all the plots. See, this is an decrement pattern, negative correlation. So this is a circle is nothing but the data points where scattered more data points, and then the thick line is a thick dot point is showing the centroid, and this is the trend line. So like this you can see here. And now going to the above, now see MPG displacement, the scatteredness is negative correlation, and you can see here minus 0.85, negatively correlated 85%. 85% if the MPG of a car is depends on the displacement. If the displacement of the wheel is more, then the mileage will be less. Like that, 85% we can say that. And coming to 78 negatively, my mileage and horsepower negatively 78% correlated. If the horsepower of the car is more, 78% there is the effect on the mileage. Maybe it's going to be decreased. 78% shows the effect. And then here you can see this 89% displacement and weight, more correlation is identified. And then here you can see 0.09, very weak correlation between DRAT and QSEC. The corresponding scatter diagram you watch here, see, data points are scattered around the plane, XY plane. There is no increment, there is no decrement pattern. That's why the corresponding correlation is also 0.09, very weak, almost close to zero. Data points are scattered the entire throughout the XY plane. Okay, I hope you understand how to find the how to visualize this more than two diagrams, and how to get the relationship between two variables. Now see, from this scatter diagram we can understand, okay, if we want to fit a regression model, so I want to take MPG, miles per gallon, which depends on the displacement, which depends on the horsepower, which depends on the DRAT, which depends on the weight, and which depends, which this is not known to consider 0.42 only, right? So maybe QSEC may not be that much significant correlation, so which it does not require. So with this remaining four variables, we, sorry, with these four variables we can fit a regression model, and we can estimate the mileage of the cars. Yeah, fine. Going to close this one. So these are the diagrammatic representations of the data. Okay, so we can go for simple bar diagrams. If you have histograms also we can go box plots, and if you want to go 2 dimensions, plot is fine. And if you want to go for 3 dimensions, you can go for the 3D diagrams, or if you want to visualize more than 3D, then we can go for like pairs wise functions. Now, additional to this one, we'll go for little advanced, that is correlation and regression analysis. I said right, there is a relationship, and we can go for regression. That also we will fit today itself. Okay, yeah, fine. Now correlation and regression. All of you know, right? What is a correlation and regression? There is no need of much elaboration about theoretical development. Okay, fine. Before going to discuss about this correlation, I want to show some PPT to you. Whether is the right time to discuss this PPT or not, I don't know. Yeah. This is slide I want to convey people. Generally, I have prepared this one. I will show you. Statistics analysis with R programming language. Already I have given what is statistics. Actually, this is the first class. And then what is the aim of the statistics? Mainly to compare the results, predict the outcomes, and R programming language. and data rich knowledge. For these things we have discussed already. What we can do with the data, visualize the data, understand the relationship, model building, identify similar entries of the objects. These are just I have discussed with you people. This one slide I will discuss, then I will go for a correlation and regression. Generally, for any research, we will divide. I have divided three types of questions. What are the three types of questions you will get? Mainly, you will get the relationship. Either you want to find the relationship between the variables, or what is the difference between the developments. So, for example, let us say I have developed one drug, new drug, and there is an existing drug is there, and I want to compare what is the effect or what is the advantage or what is the superiority of my drug than the existing one. That is the difference. So that is one research question. Otherwise, we have to go for prediction. You want to estimate the future based on the present. So mainly the research questions depends completely what based on my knowledge by seeing this data analysis. I have divided this three different types. One is the relationship, difference, and prediction. First, let me discuss about the relationship, and then we'll go for difference, and then go for prediction. If you want to go for relationship or difference or prediction, first we want to understand what is the data type. So for in every situation, what type of data we are using, what statistical technique we want to use for that. Okay. Remember, performing statistical techniques is not much tough. Even a layman also can easily see the YouTube and simply correlation regression. You will search how to perform correlation regression in R. If you type also, easily you get the comments and you can copy paste, you can work. So performing statistical techniques is not much a toughest job. It is a very easy. But the problem is that whether my technique will be suitable to this data or not. Whether I have to select one data, for this data, what techniques I have to apply. That you have to learn. That is most important question. So whenever we have data, applying all techniques is not matter. What technique if I apply, what object will be fulfilled, that you have to understand majorly. Okay, it is that is the most important part. Applying performing anyone can do, but whether the technique will be as it is exactly suitable to my data or not to get this output or to fulfill this object, what technique I have to perform, that everyone should have to understand. Okay, that's I have given a clear idea in this diagram, in this slide, easily you can access. See, first data types, we have to understand what type of data we are having in the research. Okay. For example, let us take in the relationship, if I want to find the relationship and the relationship between, for example, I want to find the continuous random variables. There are two continuous random variables, that is uncountably infinite number of values. Then how to find what technique I have to use to find the relationship between these two continuous random variables. Whenever we have two continuous random variables, if you want to find the relationship between those two, then we need Pearson or correlation coefficients. If you have any statisticians here, they might have listened this word Pearson correlation coefficient or Spearman rank correlation coefficient. The words itself tells us both the techniques are useful to find the relationship between variables only. Okay. But Pearson correlation coefficient will be useful to identify the relationship between two quantitative measurements. I mean numerical data, exact numerical data. Two quantitative measurements are there. If you want to find the relation between two quantitative measurements, we are going with Pearson correlation coefficient, direct method. Other one is Spearman rank. Here the name itself rank correlation coefficient. What is the Spearman is when we will use nothing but whenever we have a data in qualitative form. For example, let us say beauty, intelligent, IQ levels, like that. Whenever we have data which are in qualitative manner and you want to find the relationship between that qualitative variables, then we are using Spearman rank correlation. How we will convert this qualitative data into quantitative? By giving some ranks. Okay, so for the beauty contest, we will not measure the beauties 100 grams beauty she is. This boy is 1 liter handsome or 10 grams handsome. Like that we will not measure, right? Okay, so the beauty is a qualitative factor. So we cannot measure in kilograms, we cannot measure in centimeters, we cannot measure in liters. So these type of qualitative factors if we have, but still you want to find the relationship between the qualitative factors, then what we will do, we'll convert that qualitative data into quantitative by giving some ranks. And you are going to find the relationship between ranks, that is called a Spearman rank correlation coefficient. I hope you understand now. So Pearson and correlation, they have to find the relationship between two continuous random variables. No, sir, I have two categorical variables. I have some categories here and I have another categories here. I want to find what is the relationship between this categorical data. A categorical data is nothing but let us say male and female, or first rank of first priority, second priority, third priority, or lower, middle, upper. Like that, if you have category wise data and we want to find the relationship between categorical variables, then we will use chi-square test, chi-square association test we will use. These are the main two techniques whenever we are going to find the relationship between two variables. Now coming to the difference. So again, same continuous and categorical. If you have a continuous random variables and you want to find the relationship between two continuous random variables, mainly many people will suggest that the strong one is t-test. If you want to perform t-test, then again we have to decide number of independent groups or number of sample groups are available for you. Best one whenever we want to find the difference between two, a bit difference between the in your research, if you have a difference question and we want to find the relation, I will find the difference between existing or proposed, or if you want to compare the sample with population, like that, if you want to comparison purpose, damn sure we are going with the t-test. If you want to perform t-test, then we need to see the number of samples. Let us say if you have only one sample, I want to compare. Let us say I have one population and I am not able to study the entire population. From the population, I will take some small sample and I want to check whether this sample is exactly representative of the population or not. What I'm saying is nothing but whenever we have population and this population we are unable to study, what we will do? We will take the sample, right? Now, in this sample, whether the sample is exact representative to the population or not, then we want to test whether the sample characteristics, let us say mean, the sample characteristics mean will be equal to the population parameter, that is population mean mu is equal or not. The sample mean is equal to population mean or not. If you want to compare, then we want to go with one sample t-test. uh, all of you know, right? Sampling. I don't want to give much explanation about this sampling, right? For example, cooking of rice, if you take in the rice panel, so we'll take one piece of boiled rice, a piece of rice. We will see whether the rice is boiled properly or not. If the rice is properly boiled, and we will say that the entire rice is boiled. So a single piece of rice is representing the entire population, entire rice. So I want to test whether this taken sample characteristics will be perfect representative of the population or not. Let us take with some characteristics mean. Here also I'm taking mean. Now I want to compare the sample mean with the population mean. Then we will go with one sample t-test. Now, if you have two samples, let's say I have two times I have drawn sample observations, and if you want to compare one sample with one population, we are going one sample details. Otherwise, I have drawn two samples. I don't know what is the information about the population. Without knowing population, what the samples I have taken, and I want to compare whether these two sample observations are having similar characteristics or not. So, if you, for example, let us say I will take a mean. I want to compare the means of these two groups. The comparison of two groups, then we'll go with two sample t-tests. Here, one more thing is there. If the two sample groups, what I have taken, if these two sample groups are independent, that is independent sample t-test, we will perform it. If these two sample groups are depends on each other, we are going with paid t-test. I will give you an example also for paid t-test. Let us say I have a patient. For the same patient, I have tested what is the BP before giving drug and after giving the drug. Before giving the drug, what is the BP? After giving the drug, after what is the BP? Like that, I will take 100 patients. Now, these observations are depends on each other, right? Before this much BP is there. After giving the drug, this much BP is there. Now, I want to know that whether my drug is showing any effect on the patients or not. This is my research question. Whether my drug, what I have developed, is showing any effect on the patients in the hospitals. Then in the situation, we are going with paid t-test by collecting the information before and after paid information. So we will perform paid t-test and we'll get the results. That is paid two sample t-test. Now, if I have more than two sample and I have collected, let us say three groups I collected, or four groups, five groups, any number of groups more than two, then if you want to compare the means of more than two groups, then we are going with analysis of variance, ANOVA. This is one of the major tests here. Almost in the statistics, these t-test and ANOVA plays a vital role. You have to remember when we have to use this test. Okay, next, in the same difference group, if you want to find the difference between two categorical, same, there is no other option, chi-square test. Chi-square test for difference, here chi-square test for association. Now coming to the prediction, we know, everyone knows prediction. Mostly we will say the regression model is one of the best technique for the prediction. Here also again two types. Continuous, if you want to estimate the continuous random variable, what technique we have to use. If you want to go for categorical variable estimation, what what statistical test we will use. If you have any continuous, again there is support. Regression, right? Regression is the main technique to estimate the we are using for prediction. And the regression is completely depends on the number of samples. So let us say one variable I'm going to estimate based on one variable. Let us say a mileage. What the question I'm taking? The mileage I want to estimate based on the weight. Here, one dependent variable, it depends on the one independent variable, that is weight. Now, one dependent, one independent, it is called a simple linear regression model. Only one sample. I have taken the help. Now, if I take two samples, so I want to estimate the mileage of a car, MPG, which depends on the weight and the horsepower. Weight and horsepower, these two are independent observations showing effect on mileage. Now, this is called a multiple linear regression model, more than two samples. Like this simple linear regression model, only one sample. I have two sample observations are there. These two samples observations together showing effect on MPG, miles per gallon. I want to estimate MPG. Then this is called a multiple linear regression model. Multiple. And there is one more, not the multivariate regression model. This is multiple, right? We have one more thing, multivariate regression model. That is, you want to estimate more than one y. You want to estimate, for example, let us say mileage I want to estimate. At the same time, what is the drag I want to estimate based on the one variable or more than one variable. That is multivariate regression model. Okay, so we will use the regression simply for going for prediction. And here one more thing is that categorical. So if I want to estimate the patient, let us say I have categorical data, right? Let us say I want to estimate a patient is healthy or a disease. Two categories, healthy or disease, not a continuous random variable. I want to estimate whether the patient is healthy or disease. Two binary case. Whenever we want to estimate this type of binary case, depends on, let us say, their height, patient weight, patient BP, patient sugar levels. Like that, if I take many variables and based on all these variables, I want to say that whether the patient is healthy or disease. Only two categories I want to classify. Binary case. In this situation, we are going with logistic regression. I hope you understand what techniques we will use here. So these things we have to learn before going to do the statistical data analysis. When we have to perform a particular t-test, when we have to perform a logistic regression, don't blindly apply statistical techniques to the data. If you apply, you will get results. Damn sure, there is no error in that. But that errors, that results are not meaningful. I will give you one example also. That physical education department only. Yeah, sorry. That physical education department candidates only. Uh, he saw the in YouTube and he did some data analysis. In this data, there is one variable. The variable is called gender. Gender is male and female wise. The nominal variable is there. So what he did, he converted the nominal data into scale. Ordinal. That is 1 to 1 to like that. Okay, male will be 1, female will be 2. He indicated, and he converted the non-numeric into numeric. That is non-numeric is male female, right? He converted into numeric 1 to 1 to like that. He converted. Everything is fine, and he did some analysis by seeing YouTube and everything. He calculated average amount. What he did is nothing bad. He calculated the average for gender also. Gender is what are the values we have categorical 1 to 1 to 1 to. Once he calculate the average, his average is showing 1.3. What is this 1.3 average of gender? Who is it? Is it male or female? 1.3 is what is the meaning? He is asking, sir, how to interpret this 1.3? I got the average, sir. On an average in my data, 1.3 male or 1.3 female. What is this 1.3? It's a meaningless, right? So like that, you have to remember in your mind that whether the data is there, for whether my techniques will be applicable to my data or not. So this is the solution for you people. And here I have given only parametric approach. These are all the tests which are parametric, statistical parametric tests. There are non-parametric tests are there. which means that there is no any distribution assumption of the test, statistical test. Here, the techniques what I have given all are depends on the some distribution, some parametrical assumption. But in another case, non-parameter, if you don't know the distribution of the data and you want to apply a statistical technique, for example, let us take a pay test, independent two sample pay test. It is parametric approach. We are assuming data follows normal distribution. But if you don't know the data distribution and you want to apply, still you want to find the difference between two variables, then we have to go for non-parametric test, that is called Kruskal values test or ANOVA alternative. Like that, for each and every technique, there is an alternative technique in non-parametric. Okay, here I have shown all parametric tests, majorly what we are using in statistical data analysis. I hope it is clear. Now I will go back to my same data analysis R studio. Now in R studio, for example, let us take first initially I will go with correlation. So what we will do generally, we'll go with first initially what I will do. First I will see what is the relationship between the variables. Plot of MPG. Let us take weight. Now I want to estimate the mileage of a car based on the weight. What is the relationship? Is there any relationship exists between these two or not? That I will see first. Now, if I run this one, I got this plot. Yeah, there is some negative relationship. Already we know this one. Okay. Now I will check that whether this correlation is a significant correlation or not. Now, before going to significant correlation, first we'll kind of calculate the correlation. Okay. See, first I have drawn the scatter diagram. This scatter diagram showing some relationship between both the variables. I came to know that one. Now, how much the value, what is the percentage value in these two variables are related? So that I want to find the correlation. So these two are categorical only. These two are continuous data, right? So no need to worry about the correlation. COR is a function which will be useful to identify the relationship between two variables. What is a COR? MPG, comma, weight. So this is the two variables I want to find the relationship. And here you can use method. See here method. So method here, two types of correlations are there, right? One is Spearman and Pearson. So you don't want to mention here method specially. Why? Because correlation function by default it will go with Pearson correlation coefficient. Method equal to Pearson with the double quotation. Or if you are not mentioning, the correlation function by default will go with Pearson. If you are specially, if you want to say that these two variables are qualitative data and I want to perform rank correlation, then only you have to mention method equal to Spearman. Spearman rank correlation, just mention Spearman. So now these two variables are quantitative, so numerical measures. So I'm not going for any type of method. Okay, by default it will go with Pearson. No sir, I will mention means you can mention method equal to Pearson. Anything is fine. Whether you can mention or no need to mention, by default this will go with Pearson. No sir, I want to perform particularly Spearman, then only you have to mention method equal to Pearson. Okay, run this one. What is the value we got? Minus 0.8676594. If I execute this one, I got that. So these two variables are negatively 86%, both are correlated. Okay, now I want to check whether generally we know that if we want to interpret the only correlation, then we will interpret that yes sir, 86% both the variables are negative correlated. There is a strong relationship between both the variables. Strong is nothing above 80. Moderate is nothing but 60 to 55 to 80 we can consider moderate. Weak is nothing but below 50 we can consider weak correlation. Okay, so here are 86 strong correlations are known directly we can access to the regression model. No, so we have to test this correlation whether the correlation is significant or not. Okay, so for testing the correlation again same code core dot test. So correlation testing. What are the variables we are testing? One is MPG and weight. Now we are going to test the correlation between MPG and weight. Now run this one. We got this result. So car dot test Pearson product movement correlation coefficient, that is called Pearson correlation coefficient. Data is MPG and weight. Here you can see the t test. This car dot test is utilizing the t test to compare MPG and weight, their significance, and this is a test statistics value and this is the degrees of freedom. T-test degrees of freedom, right? T, whenever we are going to t-test, if it is one sample, degrees of freedom is n minus 1. If it is two samples, n1 plus n2 minus 2. What is this n1, n2 are nothing but number of samples in the groups. n1 number of samples in the first group plus n2 number of samples in the second group minus 2. Like that we'll take. Okay. Next, mostly we may not consider this one. Why? Because in the olden days, when we were studying post graduations, so we are taking table values. So sorry, calculated values. Here T is calculated value, and then we are going with table values. Statistical tables we have. T table values we have, F table values we have, like that. Every test there is a corresponding table values. Now at a particular degrees of freedom, we are seeing table value and taking the table value and calculated value, both we are comparing. If the calculated value is less than the table value, go for acceptance of null hypothesis. Otherwise, go for rejection of the null hypothesis. Like that, we are giving interpretations when I was doing PG days. But after the programs were developed highly, now all the programs are completely going with p-value. P-value yesterday I gave, right? Probability value. So completely all the programs is just displaying p-value, and interpretations easily we can give on p-value. So yesterday I said, right, if the p-value is less than 0.05, 5% level of significance I'm considering by default. So if the p-value is less than 0.05, significant we are getting. So we are going to reject the null hypothesis, accept the alternate hypothesis. If the p-value is greater than 0.05, insignificant we will get that we are accepting the null hypothesis, going to reject the alternative hypothesis. This slide also I will share with you all. I hope my slide is also visible to you. This one. What is p-value? So p-value is greater than 0.05, not statistically significant. If the p-value is less than or equal to 0.05, statistically significant. If the p-value is not statistically significant, is nothing but, so we are going to accept H naught. If the p-value is statistically significant, is nothing but reject H naught. This PPT also I will share with you all. If you want, you can take a screenshot of this one. Easily, we will remember this one. Okay. Yeah, fine. Going back to my R programming language. Yeah. Now see the basing on this p value, I will give a small direct decision about my correlation. Now what is the p value we got? 1.29e4 e to the power of minus 10. Don't look at directly the value and say that, sir, p value is a probability value. It should be lies between 0 to 1, right? How it becomes 1.2? See the focus, full focus, e to the power of minus 10. So exponential term above minus is there. So which means that before this decimal, we have around 10 zeros. 0.9 zeros after the value is 1294. What is e to the power minus 10 is nothing but minus 10 is nothing but 10 zeros you keep. Then first take 0 point, then remain 9. 9 plus the previous one is 0. 10 zeros. 0.9 zeros after the value 129. 0.0000129, which means that the p-value is almost close to 0. We know that, right? When the p-value is less than 0.05, statistically significant, which means that highly significant. If the p-value is going to close to 0, highly significant. If the p-value is close to 1, highly insignificant, we will call. Now, by seeing this, my p-value is less than 0.05, which is almost close to 0, right? Then we can say that, so the identified correlation between two variables are statistically strongly significant. Yes, this is the correlation is strongly correlated each other, highly significant. Now you can estimate the mileage of any car based on the weight or only most accurately you will get the results. And below is the nothing but 95% confidence intervals. Yesterday I said, right, again, if you take 5% level of significance, that means 5% of errors if you are allowing, 95% strong confidence you are giving about your decisions. So these are the 95% confidence intervals for our correlation. Confidence intervals. What is the chance that that value will fall between these two limits? Okay. For example, if I'm coming to the college, exactly 9 may not become daily, right? So maybe one day I will come at 9:15, one day I will come at 8:15, one day I will come 8:40. So on an average, what is the interval to come to college? Mostly I will come from 8:30 to 9:30. So this is my interval. in this interval I can come at definitely any one time. Most 90% I can be confident that. So between 8:30 to morning 9:30, definitely I will be in the college. So this is my 90% I can be confidence. At any one day I may late above 95, above 9:30 or below 9. Same way. 0.93 negative 74. This is 95% confidence. I can say that this correlation will fall between these two limits whenever we are going for sampling. Okay, here I have no need of going for sampling. Just directly I'm saying this. This is a correlation minus 0.86. Same correlation what we got in the previous, and this is the p-value. So p-value is saying the close to zero. We can say that it is a strong relationship between variables, and the p-value is my p-value is showing strong relationship. So that I can say that the identified correlation function is strong enough to fit a regression model. I hope you understand, you peoples, how we have to test. Okay, same thing. Let us say this is one direction. Okay, now let's go with it is simple integration model we can fit. I will test some more correlations. Let us say correlation of here we have taken data, right? Let us say I will take all the countries random variables, copy, and I will paste here, and I will check this what is the correlation. This is called correlation matrix. Earlier, I have mentioned correlation between MPG and weight. Only two variables. We got single value. Now I want to find the correlation between all these variables in the empty cards. That is, see, MPG, correlation is 1. The correlation between one variable to itself, that is always 1, right? So 1. Next, mileage to displacement, minus 0.84. Mileage to horsepower, minus 0.77. Like that, you have a relationship. It is a matrix, correlation matrix. I'll do one thing. I will reduce the number of dimensions, sorry, decimals. See, many decimals are there, right? Simply we'll go with a round of this function results with only 2 decimals. Now if I run this one, see, we got the correlation matrix with only 2 decimals. One is 0.85 minus 0.98. So this is the correlation matrix. Diagonal elements are 1, 1, 1. Above and lower diagonal elements are same. Correlation between displacement MPG and MPG displacement both are same. Okay. Now using this correlation, again we can go for core dot test. Let us take, I will store this correlation into anywhere. Let us take CC, correlation coefficient. Okay, these are the values I will store. Next, I will perform core dot test. CC. Why argument is missing? Oh, okay, fine. So it is asking to give only two variables. That is the problem. Okay, fine. Let's see if you want to test the correlation individually. Again, we have to go for two values. That is MPG displacement MPG. This function is showing. I want to show you entire at a time how to test all the relationship. Actually, in the base function itself, we have to get that one. Here we are not getting significance of the correlations. I want here see what I'm conveying is nothing but here we got the correlations, right? It's a correlation matrix. Earlier we got only one correlation and we tested the correlation. But here at the same time I got correlation matrix. Now I want to test all the correlation matrices. Entire correlation matrix should be whether it is significant or not. One by one I want to know. So for that, core dot test is asking only one thing. Okay, let's go with will give content data. S must be numeric. Wrong code we are doing. This is not the way of doing testing all the correlations. Okay. ggplot will be useful. ggpairs I will use. Wait. Just a minute, sir. I will use one more code. Instead of pairs, ggpairs I will use. See, I'm typing here ggpairs. When I'm typing ggpairs, but the command is not showing any suggestions. If the command is not showing any suggestions, means this command is not available in our R programming language. Maybe code is correct also. So if the code is correct, then we need some package for that. If you are typing any code commands, if you can start with 1 or 2 letters, automatically it will give suggestions in the drop down. If you are not getting suggestions, there are two mistakes. One is the code may be mistake or your code is required package. Now ggpairs is a correct code, but it is not showing any type of suggestions, which means that it required package. So I will go for installation of the package that is called ggplot. Galley one more. Galley and ggplot2. These are the two packages required. Packages are required. Yeah, we'll install that one quickly. Galley, Galley, graphics galley. One is installing. What I want to convey is nothing, but I want to test all the correlations at a time. I don't want to test individually to one mileage, horsepower, mileage, this like that. I don't want to test. I want to know whether the correlations, all matrix correlations are significant or not. So this is okay. So Galley, Galley. Here already we installed ggplot2, right? Just I click both. Fine. Now I will run this one. I will write. See. Now see, once you install this zgalley and ggplot, automatically you are getting drop down box suggestion, which means that now it's the code is available. Okay, zgalley. Now I will run this one. What the code or what the data set I have taken. Yeah, it's working. Yes, zoom it. Same matrix color diagram, sir. So to represent the matrix data more than two dimensions, again we can use this one more function gg pairs. Now in this better results we can discuss. See, the diagonal elements are called densities of the variables. As we discussed right earlier, we got in the page that panel, we got histogram overlaying density. Here only we are getting densities, and the below are the scalar diagrams for each and every combination, and above are the correlations. COR is the correlations. Here the best advantage is that here we have the stars. See carefully. If I take the relationship between MPG and displacement, the correlation is having minus 0.848, and above we have 3 stars. Whenever in the data, in data analysis, wherever you will find, if anywhere, if you find star, remember the star represents significant. If only single star represent, it is a significant at 5% level of significance, which means a 95% confidence that the value is significant. If you get 2 stars, then 1% level of significance, your value is significant. That is 99% confidence you can say that the data is valid one. If you're getting 3 stars, completely 100% is highly significant. 3 stars represent highly significant, 2 stars represent at 1% level of significance, highly significant, and 5% 1 star, 5% level of significance. 3 stars, 0% level of significance also we can say that. 100% confidence you can say that. Now see here, the correlation 3 stars. The correlation between MPG displacement is highly correlated, significant highly. And this is also high correlation, high significance we got. And here so you can see this one, the correlation between DRAT and then what is this HP. The correlation between DRAT and HP is having little weak correlation negatively. However, there is a significance. Minus 0.44 at 1% level of significance, it is showing a significance. And this is a highly significant, highly. This is C, single star we got. Even if you get 41% correlation in both the variables, that too is showing significant. I said that one example. If whenever sometimes we'll get a low correlation, even though significance is occurred. Sometimes we get a high correlation, even though not significant. See here, star, single star at 5% level of this is also significant. Any weak correlation? Here you can see this. There is no any stars. If it doesn't appear stars, nothing, it is a insignificant. Here also no significance. So the relationship between weight and QSEC, no relationship. The relationship between DRAT and QSEC, there is no considerable correlation exists. They are insignificant. Stars represent significance, and here in R programming showing the empty, no, without stars. Sometimes in R program itself only, or in SPSS also, I saw that it will represent the dots as a dots, insignificant values. Significance values represent the stars, and dot which represents insignificant. Stars are something was significant. Dots represents insignificant. Single dot insignificant. 2 dots highly insignificant. 3 dots is completely insignificant. No use at all. I hope that now this is the helpful for us to consider whether these correlations are significant or not. Hope you understand. Yeah. Now simply I will, instead of going with order test, so already I have performed this one. Now easily I can understand what are the correlations are significant. Now I will fit a small model and we will conclude today. Already I have loaded, I hope more loaded for you people. Okay, we'll go with simply with fitting a simple regression model. I'm not verifying any assumptions of the regression model. Simply I will go for regression model fitting. Okay. If you want to fit a regression model, linear regression model I'm fitting by assuming that the both the variables are linearly related to each other. So their correlation is what the correlation I'm taking. This is the MPG and weight. So MPG and weight, I'm going to fit a regression model. So I'm considering MPG is a dependent variable which depends on the weight, independent variable X. Okay, so I'm taking only two variables. That is simple linear regression model I'm fitting, and I'm testing whether how much percentage or how much I can truly estimate my MPG based on the given weight. Okay, that regression prediction we will do. Okay, see, so if you want to fit a regression model, LM represents linear model. I'm fitting linear regression model, right? So that's why the code is LM. So within the bracket, first we have to define independent variables. What is the independent variable here? Sorry, dependent variable. What the dependent variable we are going to estimate? MPG, right? Give that variable MPG. Next, tilde. Yesterday, some madam has used it in the box plot. Okay, same that. Tilde. Independent variable. What the independent variable we have? Weight. So linear model of first dependent variable having tilde with independent variables. So comma data. Where we are taking the data? Data is empty cars, right? Empty cars. That's it. Very one line. If you see the regression, we have to derive the regression model. First, we have to write the regression model. The regression model is, what is the regression model? Y equal to, so let us say beta naught plus beta 1 x plus epsilon. Let us say E. This is a regression model, right? Simple linear regression model. Let's go with SLR. SLR, simple linear regression model. If you have more than one independent variables, we will call multiple linear regression model. Now see, from this equation, we want to estimate beta naught and we want to estimate beta 1. These are the two parameters of regression model. So simply we will say beta naught is a intercept and beta 1 is a slope. Okay, these two parameters we have to estimate. So if you want to estimate the parameters of regression model, we are going with ordinary least squares method, OLS method, minimizing the residual sum of square. So we have to take an equation, residual sum of squares, then we have to derive the normal equations by partially differentiating with respect to parameters equating to 0. Then we'll get the equations, and upon solving these two equations, we will get the parameter formulas beta naught, beta 1. Then in the formulas, we have to substitute the original data so that to estimate the equation. Okay, this big procedure is there, so you don't want to bother about that. If it is a simple integration model or multiple integration model, whatever it may be, just a single code, LM linear model within the parentheses, give the data. That's it. Okay. This is called sorry, if any mathematicians here, you can call, sir, it is y equal to mx plus c. MX plus C or beta naught plus beta naught, both are same. If any mathematicians see here, if you are not, if you don't know about statistics regression model, then you can take beta MX plus C equation easily. Okay. Now if I run this one, yeah, simply we got. So what are the coefficients? The estimated parameters. One is intercept, other one is slope of the regression model. So now from this, so I will draw equation. So MPG, miles per gallon, which is equal to, what is the intercept we have? 37.285 plus, what is the plus? We have minus here, right? Minus 5.344 into, what is the value? Weight. So within multiplied by weight. This is our fitted regression model. Fitted regression model. There is no error. Our assumption. Okay, there is no any error. A fitted regression model. Simply write. See, we got a regression model. Now I want to see what is the accuracy of this model. How much accurately I can say that this model is significant, or whether my model is significant or not, or my model, how much accurately I can estimate the mileage of a car for the given value of weight. Now see, if you substitute the weight here, automatically you will get a mileage, right? Let us say your weight of a car, if you, for example, if you purchase a new car, your weight is 2 tons. Let us say you substitute here 2, then you will get mileage value. So on an average, so this much mileage after 2 tons car will give. That you can estimate, right? But we have to give how much accurately. You can say that your model is good. That we have to find, right? Even though first we have to understand whether the identified model is significant or not. That is also we have to verify. So for that, so just do one thing. So this model is the right. Store this model into any one object. Let us say I will store in SLR only. Simple linear regression model. I have stored. I am running this one. Yes, I am storing my output, the model output into SLR. Now take this summary of my model, that is SLR. Summary is nothing but descriptive statistics. Just a minute. SLR. So summary of SLR, if I click, then you will get full description about your model. Yeah, I have executed this one, summary. Yes. Now see, sir, summary I perform this one. This is a method how I perform, and these are the residuals. What is a residual? Residual is nothing but it's like a kind of error, right? So what is the residual? What is the error between fitted point to original point? That I will discuss once I draw the graph and regression line. I will show you. As of now, keep that aside. Next, coefficients. One is intercept, other one is weight. So what the model I have drawn? Intercept is 37.8, the same model I have run. Next, minus 5.344 is the coefficient for the regression. Okay, that weight. Next, standard error. These are the standard error while estimating these parameters, and t-test statistics to test the significance of the parameters, not the entire model. Here, testing the significance of the parameters. And you can see this directly, stars. You don't want to look at the p-value also. P-value is less than 0.05. Below, above, both the p-values are less than 0.05. You don't want to test. By default, we get the testing and with the stars. So both are representing 3 stars. 3 stars, what is the meaning of 3 stars? 0% level of significance, both the parameters are significant, which is a highly significant parameters. Very good. Next, this is the interpretation of significance of the course. 0 means 3 stars, 1% is 2 stars, 1% is 5 stars, like that meaning of these stars. Next, residual standard error will come to later, and this is the required multiple R square and adjusted R square. This one line you have to consider from this summary of the model. This is a main line, which is only the accuracy of model. What is this multiple R square? Multiple R square is nothing but square of the correlation coefficient. We have correlation, right? Minus 0.83 something. If you square that one, you will get the multiple R square value. So what it tells us, multiple R square or adjusted R square. First I will discuss multiple R square, then I will go for adjusted R square. Both are same only, similar. So what is this multiple R square is nothing but the percentage of variation in dependent variable is explained by the independent variable. How much accurately, what is the percentage, how much I can estimate the variation in my y, that is dependent variable here in my MPG. So how much variation in the MPG can be explained by the independent variable weight. So if the weight is perfectly explaining about my y, then I can estimate my y, right? Understand? So if my independent variable weight is clearly expanding the percentage of the clearly expanding the variation between the dependent variable MPG, then easily if I give weight, automatically that correctly estimate my y, right? That is the one thing. Multiple R square. The percentage of variation in the dependent variable is expanded by the independent variable. Okay. Here, how much percentage is expanded x by the with the independent variable y? Okay, so here you can see this multiple R square value 0.75, which means that 75% you can accurately estimate the value of mileage based on the given weight. Okay, remember in the real life, many times many people will show you their model accuracy, that R square value, multiple R square value will be 99, 90, 97, like that they will show more accurate. But remember, if you have any one real original data, the data is not contaminated one original data, your R square value will not be more than beyond 9. But definitely it will become below 9 or below 9.3, 9.5, below only. Never ever you will get a 99%. Why? Because future, right? We are estimating future. We cannot say 100% or above 95% that exactly this will happen tomorrow. That we cannot forecast. Just approximately we are estimating everything. In the future we are assuming, but there is no guarantee that 100% this will happen. By seeing outside weather environment, many people will say, sir, tomorrow there may be rain, today cloud is this much. Who knows that tomorrow exactly will rain? So don't believe that if any candidate or anywhere, if you saw 99% your R square value or 95 above R square value, don't believe that. There may be a overfit of the model. It is not exact fit, overfit. There are two sets. One is lack of fit and overfit. Lack of fit, overfit, both will happen due to assumptions. The regression model is having around 8 assumptions. Now I am saying that the multiple R square is 0.75, 75% I can estimate. No, I have to verify the assumptions also. Once these 8 assumptions is satisfied by the regression model, what the model is fitted, if it is satisfied, then only it is a perfect one that 75% accurately you can estimate the value of mileage based on weight. If the assumptions are violated, again you need to tune or you need to modify your model according to the satisfying the assumptions. Remember, assumptions are more important for the regression model. Okay, here I'm not going to explain about the assumptions, just I will show you what the model and how it will be work. Okay, now coming to the adjust R square value, this is little advantage than the R square value. So what is the, if it is simple in regression model, does not worry. Adjust R square value does not require to consistent. But if you have multiple regression model, then adjust R square value is required. So how it plays is nothing bad. For example, let us say one y is there, one x is there. You have put a regression model, you got the accuracy is this much. Now let us say the same y I want to estimate based on two independent variables. Now I have added x1 first variable as it is same in the previous model. Now additionally I have added one more variable. Additionally, I have added one more variable. Two variables I have added. Now, if I add one more variable, definitely the variation in y will be increased. If the new addition variable is having a relationship with y or not, whatever it may be, if addition new independent variable to the model, definitely the variation in y can explain easily more. If it is relevant or irrelevant, so the R square value will increase. If you add one independent variable, R square value increase. If you add one more independent variable, R square value will increase. So keep on, if you're adding independent variables, R square value will increase. It will not understand, it will not think about whether the addition new variable is relevant or irrelevant to the model. But adjusted R square value will focus that one. If we adding new variable to the model, if the new variable is literally significant effect, showing effect on y, it is required for your model, then only it will increase the accuracy, the additional R square. If it is additional new variable is not showing any effect with y, simply you are adding for an increase in variation means the adjusted R square value will not affect, will show the same thing. That is the one advantage for this adjust R square value. So that we can, so whenever we are going to multiple regression model, if you are fitting regression model more than one variable, then consider this adjust R square value. So now see both are similar. So let us take with the R square value, adjust R square value. I can claim that 75% my model is best fit. Okay. Now simply I will perform multiple regression model. Same copy. I will finish this one. Paste. Now I will go with multiple regression model. Let's say MLR. Now MPG. Let us take. I want to add one more independent variable. Let us take horsepower, HP. Why? Because horsepower and weight both are showing effect on MPG, right? I will add one more variable, that is horsepower. Now I will run this code. Yes, executed. I will see what is the MLR we have. This is the model we have. Now I will get the model is minus 5.37.227. 227. Let us say 3 digits I'm taking. Minus 3.877 weight, and then minus 0.031 into horsepower HP. Okay, this is my fitted regression model, multiple regression model with two independent variables. Together I'm estimating my mileage. Okay, now take a summary of MLR. Now you can see here, in this case, coefficients. So estimated values, these are and this is the standard error while estimating these estimates, and test statistics value and significant. Okay, fine. All are significant. Two are highly significant and one is significant at 1% level of significance, no issues, significant. And here you can see this multiple R square value, 82. And you can see adjusted R square value, 81. Yeah, okay, fine. So 81% with these two variables, you can estimate accurately your regression, your MPG. Okay. Now, I will the last case I will show you. Let us see here plot what the values we have taken. So here one dependent variable is MPG, right? So first we'll give x-axis, that is weight and MPG. What is the explain differ? What happened? Will it test this one?
So Shiva sir, Shiva sir.
Sir,
Yeah, many are left, sir. I think they are going. Can we continue tomorrow?
uh,
Yeah, because
okay, sir,
from
fine.
80 participants came to 40.
Yeah, fine,
Again,
sir.
they
Okay,
may,
then.
yeah, what main thing is again they may miss. They will ask again for me. Sir, you kept
Yeah,
only
yeah,
four like
fine.
that.
Yeah, fine, sir. Then okay, I will stop here, sir. If
Yeah,
you
yeah,
have any
thank you.
doubts, you can ask quickly.
Yeah, okay. Participants.